Welcome back. So we're going to continue our discussion about functions, and then we'll start introducing some new definitions, some extra definitions for functions. So here I have a couple of examples that I would like you to try. So, and I just, disclaimer, I'm not saying that what I'm saying are all the options, it's just some of them. Okay. So let f go from x to r such that f of x equals square root x. Who could x be? Who could it be? Well, we could do something crazy like just the set containing 1. Nothing can stop us from that, right? So because 1, square root of 1, 1, it's going to be an r. You could just pick a couple of numbers like 2, 4, 102. So if you can, so maybe you can see now, like, or maybe it's 0.102. So as you can see, like, you can get funky with it, you can get experimental, so it's not always like cut and dry. We could do r plus, we could do r plus union 0. So that's like the interval from 0 closed, including 0, to infinity. What else could we do? Natural numbers. So integers we're not going to be able to do. You might know some things about square roots of negatives, but we're going into the reals, so that won't work out for us. So maybe that's someone we could say x is not. So maybe I'll use green for what it's not. Ooh, green and orange. Those are great fall colors. Okay, so x can't be the integers. It can't be -1. Maybe you know about the complex numbers. If you don't, that's okay. Don't freak out. Yeah. Or maybe, oh, that's a good one. R plus union -2 or something. That's not going to work out. Sorry, I know they're all conjoining together. Okay, so how about the next example? Let f go from x to r such that f of x equals square root of 10. Oh, I guess I'm supposed to say what x could be. Well, fun fact here, doesn't matter. Okay, so x could be any non-empty set. So why is that? Why does that work out? Well, I don't care who you plug in as x, you're still going to get square root of 10. And that's always going to be in the reals. So we're all good. We're all set. As long as you don't have any elements to plug in there, we're good. We got a function. Okay, so even if you plugged in like -1,000, f of -1,000, square root of 10. Because it doesn't matter what you're plugging in as long as you're plugging in something. Okay? All right, so next one. Okay, cool. Oh, right. I wanted to introduce this notation. It just means G is defined as going from the domain to the codomain. And then below it, I have written here what the elements do, what the rule is, what the assignment rule is. So this comes from the n cross n, all right? And then G applied to that gives us a over b and x. Okay, and then the a and the b aren't random. A comes from here, b comes from here, and it's the same elements when you move over here. So I wrote down here, another way to say that is this, okay? But notice it's not just an arrow, it's like this thing, where it's got this line on one side and then an arrow. So how this reads is a comma b maps to a divided by b. So this is maps to, okay? All right, so who could x be? Well, it could certainly be the rationals, because rationals are just fractions of integers, and naturals are in the integers. Oh, but okay, so now I understand why I chose naturals, because naturals don't have 0, so I don't even have to worry about like saying 1b is not 0. So we could do that. We could talk about the reals. It couldn't be the integers because we can't always guarantee that. What if a is 1 and b is 2, for example? Yeah, we could get creative with this. Could be the positive reals. Okay. All right, so now here's a rapid fire one. I will show you a map and define what rule the map will need to follow. Oh my gosh. Sorry, I'm not the best writer. Okay, so what I'm trying to get at here is I show you the domain and the codomain. So before I was giving you an assignment rule, and then you had to figure out who the domain, who the codomain could be. Now I'm giving you the domain and the codomain, and now I'm asking you to produce what an assignment rule could be for that. Okay? All right. So when we talk about functions, we typically, functions that are between polynomials and stuff, or they go from the polynomials to numbers and stuff. Whenever they deal with polynomials, we typically capitalize those function letters. You don't need to. It's not like we're going to take off points for that, but just so you know. Okay. So t going from the polynomials of degree or lower, including 0, minus the 0 function, mapping to the set containing 0, 1, 2, or 3. Oh, well, okay. So this is one option. If you came up with another one, I'd love to hear it. You can email me. You can email me about any of this stuff if you ever have questions or comments or anything. Okay, or feedback. Trust me, I really want constructive feedback because I want to make sure that I'm doing the best job I can for you all. Okay, so what we could do is we could define t of f equals the degree of f. Okay, so you take some polynomial from its domain and you just see what its degree is. And since we're in P3 minus 0, all of those functions are going to have degrees 0, 1, 2, or 3 by definition. So here I have Pn cross Pm and then them added together. Okay. So my thought is if I multiply to, so it's like if I have like x to the 4th and x to the 3rd and I multiply them, I'm going to add their exponents. Okay, so in fact, this is actually a very interesting result. If you multiply, so let's say f of x times g of x, so the degree of f of x times g of x, okay, so I hope this makes some sense. Basically, what we're saying is you determine the degree of a function by its highest exponent, right? So when you multiply f and g together, you get a whole bunch of stuff, but you know what that first term is because the first term or the highest exponent is just going to be the multiplication of the highest exponent of f and the highest exponent of g. Okay, so, and like I said before, you would add those exponents. Okay, so we have degree of f plus degree of g. How I'm going to define this map is maybe I'll write it below. So why did I talk about all this over here? I talked about all that over there to show you that it's okay to multiply f and g together and still end up here, okay? Because the maximum degree that f can have is n, and the maximum degree that g can have is m. So the maximum degree you can have by multiplying them together is going to be n plus n. Okay, it's going to be if f does have degree n and g does have degree m, and you multiply them together to get degree n plus n. Okay, and then if you have lower than that, you're still lower than that, right? And 0, that still all works out fine. Okay. So I hope this makes sense. And now what else I would like to say is about these brackets. So g sends functions to functions. So g has nothing to do with the variable. That's why the variable x is out here, because g only deals with functions. Okay, so g takes in these functions and then spits out another function. Okay? And these functions that G's like eating and spitting out or whatever, however you want to picture it, they do have a variable. So here I'm enclosing G just with its functions because that's the only thing that G cares about. It doesn't really care about our variable. So if you think about it, in the G of these two things is a polynomial because I'm handing it to, because it is a function, so it is going to land over here, which means that it is a polynomial. So polynomials need to have a variable. So that's why sorry, this is like so hideous now. Okay, so that's why I have G sectored off here, but I know that this is a function, so I know this is a polynomial, so it needs a variable. All right, and then over here, that probably doesn't need a whole lot of explanation because that's what you're used to looking at. Does that make sense? I hope that makes sense. H goes from P1 to P2. Okay, there's a lot of things we could do with this. H could be, it just sends F to F, right? Because P1 is a strict subset of P2. We could also have that H of F, and so this is the one I really wanted to talk about. It could be an integral. I'm going to write F of S ds. Okay, so F of S ds, the integral from 0 to x. So that might be a little bit confusing because you're like, where's this S coming from? Well, when you take the integral of something, remember you have to plug in stuff. So you don't just get, because we don't want an indefinite integral. Okay, we want to know what that constant term at the end is. We don't just want a plus c at the end. Okay, so we have to set up something here. So what I chose was 0 on the bottom and x on the top. There's other ways you could define it. You need x somewhere in there because you need these two things to have the same variable. But yeah, so when you say the integral of something, you go up in degree. And because we're going to P2, that's okay for us to go up 1 degree. Okay?